and welcome to day 2 of the CE10 Public Program. For those of you that weren't here yesterday, my name is Neil Fromer with the Resnick Sustainability Institute, Caltech's hub for research in renewable energy and sustainable use of natural resources. Yesterday, we learned a lot about the current energy and climate landscape and some of the challenges and opportunities to try and reach a 50% reduction in nationwide global warming gas emissions in the next 10 years. CE10 is a collaborative effort led by Harry Atwater from Caltech, Lambertus Hesselink from Stanford University, and David Welch, founder of For Good Ventures, with additional support and sponsorship from Caltech's Division of Engineering and Applied Science and the Resnick Sustainability Institute. Before we get started for the day, just a reminder to please use the Q&A feature to ask questions of the speakers during their presentations. I'll come online near the end of each talk and ask as many questions as possible given the time. And we'll end each session promptly to try and keep us on time for the day. For the same reason, I'll also be keeping my introductions of the speakers brief, but full bios for everyone are available on the CE10 website. We'll start with today's introductory remarks given by CE10 organizer Bert Hesselink, professor of electrical engineering at Stanford University. Bert?
Thank you, Neil. Welcome everybody to the second day of CE10 at Caltech. Today, I'd like to talk a little bit about the Sankey diagrams and what they specifically can teach us in terms of the energy ecosystem. So let me share my screen. The question that we raise is, how do we actually reduce global warming gas levels from 2005 by 50% in 2030? And yesterday we heard a number of proposals as to what could be done. And the question is, why have we not made more progress? In 2005 till 2019, the US essentially reduced global warming gas by 1% per year. That means that we're only 14% down the road for achieving 50% reduction by 2030. Unfortunately, the next couple of years after the pandemic, the global warming gas is predicted to go increase instead of decrease, which leaves us roughly about 6 years to achieve that, which means that the rate of increase in decarbonization has to be 3 to 4x for the rest of the decade. And there are a number of potential pathways, but the question is which ones are practical and which ones can actually be implemented so that they will be successful. And how do we actually increase this rate of decarbonization in a organized manner so that we achieve our goal? So some of the strategies appear to be what I would refer to as Excel physics. So if we could make so many % of the transportation sector electrical, then we would save the following percentage in global warming gas. And of course, these diagrams will provide us with that type of information. So the objective of this meeting was to try to find out what is really a realistic set of strategies that we can follow. And so the first question is really to identify these high probability pathways. So these are pathways that with current technologies can be scaled to achieve the level of reduction in global warming gases that we desire. And like many other choices in life, this has to be done at a certain cost. And so typically in the free market, the lowest cost solution tends to win. And there is a third aspect of it that is an important aspect of this meeting, which is essentially how do we get public support, including those that doubt that there are issues with global warming, on board so that we collectively try to find a solution to this problem. So let me give you a couple of examples as to how we could use these Sankey diagrams. So if you look at the Sankey diagrams on the left-hand side, we essentially have all of the components of the supply side, all the way from solar to petroleum. And then this energy is being converted into either electricity, or it is being utilized in residential, commercial, industrial, and transportation applications. What you see on the right-hand side is that there's rejected energy and energy services. So when you look at the whole system, so the US energy system is roughly about 30% or so, 32% efficient. So you take the total rejected energy, put it total energy services, and you look at the ratio. So the question for the meeting participants was, how do you actually rewire these diagrams in order to be able to reduce the global warming gases? Now, there's some other interesting results that you directly can get from this, is that transportation is only like 21% efficient. If you look at the system efficiency, is a little bit more, and that's 33. Electricity generation is about 35. Residential is already 65. Same for commercial, and industrial is only 49. So what does this mean? Well, when you look now at the electricity generation and you look at the carbon emissions, we need somewhere on the order of about 2,200 million metric tons, so 2.2 gigatons by the end of 2030. And what you see in here, that actually the contribution of the renewable energies, when you go back here, you can actually take the solar, nuclear, hydro, wind, and geothermal contributions. And what you find is that it is a relatively small contribution. So gas dominates, and there is still coal. So when we look at all of these, you might ask yourself, suppose that you're Secretary of Energy, and you need to make decisions about which way to go, and you have limited resources, where would you actually place your bets? Well, transportation, electricity generation, and industrial are the biggest contributors. Residential and commercial only have a relatively small impact, on the order of about 4 or 5% or so. So what are we going to be able to do? Well, the first thing you obviously could do, and this happened over the last 14 years or so, the lowest hanging fruit, is let's just get rid of coal. So if we take coal out and we replace it by natural gas, then that takes roughly about 486 gigatons of global warming gases away, CO2, or about 20% of what we need to do. But there's still roughly about 2 gigatons that we need to remove from this process. So we need to do other things as well. Now, obviously, you could say we can make all of the transportation electrical. If we did that by some magic wand, tomorrow there will be no more internal combustion engines, no aircraft, no transportation trucks. We still have not solved the problem. And so we reduced it by about 71%. We still have to remove 600 or so million metric tons of global warming gas. And then we say, well, there's another option here. So all the homes, by some magic, will also become all electric. And that saves us another 339 million global tons of global warming gas. So the reason that I'm bringing these up is that these options are all very complicated, very expensive, and very hard to implement. So it is a daunting issue. And unfortunately, if you took heat pumps and you compared those with, say, gas furnace in the United States, it turns out that not in California. In California, actually, it would actually improve the situation a little bit. But in the US, the extra power that is required would come from marginal emissions. Then the global warming gas emissions would increase, not decrease. So it is absolutely clear from this short discussion that if we go back to what our options are, if we want to reduce this process in terms of generation of global warming gas, what we need to do is to try to find ways of drastically increasing the amount of renewable energy that can be generated and can be applied for different applications. So coal is obviously a first low-hanging fruit, but there is a role to play for all components of this ecosystem. And it is highly unlikely, based on the information and where we are at the moment, that this could be done with just purely solar and wind applications. We would have to have other forms of energy, and particularly there is a question of what are we going to do with nuclear power? Are we going to shut it down, or are we going to maybe use it for a while longer? And this is also a largely economic question, as well as a question that has to be decided to some degree by the public. Are they willing to support essentially nuclear power plants that have turned out to be safe, but have other safety concern in terms of waste, etc. But we see now that even if by 2035 in California, you don't sell any more electric cars, you still haven't solved the problem, because that if all the new cars are essentially going to be electrical, the actual fleet composition will probably not be more than 20% electrical compared to what it is today. So I will essentially stop here. And the hope is that the speakers today will provide us with insight into their potential pathways that we could reach this global warming gas reduction that the US has pledged. And secondly, we would really like to know what is the probability that these pathways can be achieved? What would it cost? And what will we need to do in order to get the support of the public so that we actually can make this a very high priority topic? So this is my short introduction. And Neil, I'll turn it back to you.